Ever felt like you need a super assistant? I mean, not just somebody to answer your questions, but to actually solve complex problems for you, to think strategically, plan ahead, maybe even learn from its own mistakes.
Hmm.
Imagine an AI that takes the initiative, pursuing your goals with, well, remarkable autonomy. We're talking about AI agents, and believe me, they are rapidly moving from science fiction into our daily professional lives. Welcome, curious minds, to the deep dive. This is where we take a stack of sources. It could be the latest research, expert insights, real-world case studies, and we boil them down into the most important nuggets of knowledge.
Right.
Our goal, to give you a powerful shortcut to being truly well-informed. And today, oh boy, we're unpacking something that's poised to fundamentally disrupt how we all work.
Absolutely.
We're plunging into the fascinating world of AI agents, and specifically the architectural design patterns that make them tick. It's about understanding how these autonomous systems go far beyond simple chatbots to become, well, proactive, intelligent problem solvers.
And to guide us through this pretty intricate landscape, we've synthesized insights from a really rich array of cutting-edge sources. We've got a comprehensive agent design pattern catalog from CSIRO that gives us a solid, structured blueprint for building these systems.
Yeah.
We've also drawn practical wisdom from industry leaders, think Andrew Ng, alongside real-world applications from big names like MongoDB, Anthropic, AWS, and Google Cloud.
So the theory and the practice.
Exactly. And what's particularly fascinating, I think, is how we'll also connect these design principles to a very candid analysis of why these complex systems sometimes just don't quite hit the mark. That's thanks to some crucial research from Pawn House data.
The reality check.
Precisely. Which raises a fundamental question, really. How do we build these sophisticated systems to be truly robust, reliable, and importantly, trustworthy?
Okay, let's unpack this. It's genuinely mind-bending to witness AI's evolution. I mean, from just fetching facts to proactively accomplishing goals. That's a huge leap. And these design patterns we're about to explore sound like the secret sauce, the professional blueprints guiding this incredible transformation. All right, first things first. Let's get our bearings, clear up some common confusion maybe. You hear terms like agentic AI and AI agents thrown around a lot.
Constantly.
Are they just fancy new ways of saying chatbot? I suspect not quite, and maybe this distinction is really crucial for understanding what's truly new here.
Indeed, it's more than just semantics. Agentic AI represents a more holistic and advanced approach to large language model, or LLM autonomy. It defines systems where LLMs autonomously perform complex tasks start to finish.
Okay, start to finish.
Right. This isn't just about responding to a prompt. It's about the LLM being delegated significant decision-making authority. That allows it to proactively pursue and achieve a user's goals. Think of it less like a conversation partner, more like an intelligent, independent executor. Now, within this agentic space, we really need to make a key architectural distinction. It's between what we call workflows and AI agents themselves.
Workflows versus agents. Got it.
Yeah. So when we talk about workflows, we're referring to systems where LLMs and their tools, they're orchestrated through predefined code paths. These are generally more deterministic.
Deterministic meaning predictable.
Exactly. They focus on decision-making with predictable outcomes because their sequence of actions is largely prescripted. It's like a very smart, automated process that follows a meticulously planned checklist, very step-by-step.
So if I'm picturing this right, a workflow is like a super smart, very precise factory assembly line. Can you give us a concrete example, something that brings that to life?
Precisely. That's a very apt analogy. Think about processing an invoice. In a workflow, an LLM might be given a specific set of tools. One to scan the invoice, another to extract specific data fields, vendor name, amount, due date, that sort of thing.
Right.
And then maybe a third tool to meticulously input that data into a standardized accounting form. The user might still review and upload it, for final checks.
Sure, the human oversight.
Right. But the entire path for the LLM is clearly set, it's predefined, and highly predictable. Each step just follows the last in a fixed sequence. Conversely, AI agents, this is where LLMs dynamically direct their own processes and their own tool usage. They maintain profound control over how they accomplish tasks.
So they're in the driver's seat.
Completely. They possess genuine agency to make and take decisions on the fly. This means they can pick any number of tasks in any order and even decide to create new subtasks as they go, all to accomplish a given high-level goal. It's far less rigid, much more adaptive as circumstances unfold.
Okay, let's unpack this a bit further. So if a workflow is like a carefully planned road trip, Every stop, every turn mapped out in advance. Then an AI agent sounds more like being handed a destination and just told, figure it out yourself, just get there.
Uh-huh. Yeah.
That's a bit wild, isn't it, in the best possible way? It sounds like the AI is acting like a professional project manager, not just a data entry clerk.
Yes, that analogy truly embodies the core difference. It's all about autonomy and initiative. For instance, a software agent might only be given the high-level goal, create a website with the game snake.
Okay, simple goal.
Seemingly simple. But the agent then has to autonomously define all the necessary subtasks, like researching web frameworks, writing the HTML, the CSS, the JavaScript, debugging it, testing it, maybe even iterating on the design.
Wow, okay.
It performs them, and then it reflects on its progress and outputs to ensure the tasks actually meet the desired outcome. It's a self-starting, self-correcting entity, moving way beyond a predetermined script.
So why does this distinction matter so much for us? For you, the listener, who might be thinking about using or building these systems, what's the practical takeaway here?
It's a very important practical consideration, actually, especially for effective professional deployment. See, many problems in the real world don't actually need the full dynamic autonomy of an AI agent.
Right. Sometimes simpler is better.
Exactly. Agentic workflows often suffice. They provide ample power and efficiency while offering greater predictability and consistency for well-defined, structured tasks. As research from places like Anthropic and Google Cloud clearly indicates, going for full autonomy when it's not really warranted, well, it can lead to higher costs.
Because it's thinking more, using more resources.
Precisely. Increased token usage, more computational complexity, and it can also result in less predictable outcomes sometimes. So it's really about choosing the right, most professional and most cost-effective tool for the job, rather than just grabbing the flashiest one. And looking back, at the bigger picture, the evolution of generative AI has followed a pretty clear progression, moving steadily towards this agentic paradigm. In the past, AI models were trained on specific data sets for very specific, narrow problems. It required a lot of human oversight to make sure they were performing correctly.
Right, very supervised.
Very. As we move towards a more fully realized agentic world, intelligent multi-agent systems will make increasingly complex decisions and coordinate with significantly less human oversight. This shift, it's poised to completely transform how we work and innovate across countless industries. It's a profound systemic shift we're witnessing.
That sounds incredible, truly revolutionary, but also a bit mysterious. Like a black box, maybe, we can't really see inside, leaving us wondering how it actually got to its answer. Is that a fair concern?
You've hit on a core challenge, and it's a very valid concern. The industry is actively working on this. The sophisticated internal architecture of these agents and the underlying foundation models. Yeah, it often results in limited explainability,
Right.
making them indeed feel like black boxes to stakeholders. As the CSIRO paper, the Agent Design Pattern Catalog, highlights, this lack of transparency can significantly affect their reliability, their robustness, and their overall trustworthiness. It's just inherently difficult to trust something whose internal reasoning process you can't fully understand or inspect. And this growing interest in foundation model or FM-based autonomous agents, like those early, highly autonomous systems, AutoGPT, Baby AGI,
I remember those making waves.
they really did, and they really amplified the urgent need for systematic knowledge to guide their design. These pioneering systems, while showing immense potential, they truly highlighted the practical challenges developers face. Specifically, they struggled with inherent hallucinations.
The AI just makes stuff up confidently.
Exactly.
Got it.
Confidently wrong. Then there's the black box explainability problem we just talked about, and complex accountability issues. I mean, when an autonomous agent makes an error, who is responsible?
Good question.
These are serious questions that require systematic professional answers and clear design principles.
So, if I'm understanding this correctly, they're not just answering questions anymore. They're solving complex, open-ended problems through dynamic exploration and iterative refinement. They have autonomy, adaptability, sophisticated decision-making at their core. That's a significant leap forward, truly beyond just a basic chatbot or even a very smart workflow. Okay, now that we understand the what of agentic AI, let's dive into the how. Andrew Ng, who's, a true luminary in AI, a visionary.
Absolutely.
He's articulated 4 foundational design patterns that are proving incredibly effective for building these systems. He even made a pretty bold statement suggesting that these patterns could drive more significant progress this year than maybe even the next generation of foundation models themselves.
It's a strong claim, but it speaks volumes.
It does. After seeing what they can do, I'm starting to believe him.
Indeed, his emphasis really speaks to the power of structured thinking and intelligent architectural design in AI development. So, the first of these pivotal patterns is reflection.
Reflection.
If
Okay.
reflection is essentially the AI equivalent of critical self-assessment and continuous improvement. It's where the LLM rigorously examines its own work, its outputs, its reasoning process to identify flaws or opportunities for enhancement, and then comes up with ways to improve it.
So it critiques itself.
Exactly. Think of it like automating a human writer's process, drafting, meticulously getting feedback either internally or externally, and then diligently revising until the work is polished. It's about embedding that internal editor directly into the AI's core capabilities.
So it catches its own mistakes. That's quite something. Imagine my own email inbox. If I had an AI assistant that could do that before I hit send, my professional life would be so much smoother.
Haha, wouldn't that be a game changer for all of us?
Yes, precisely. The process typically involves an initial generation, maybe a response or a plan. Then comes a self-reflection phase, where the model scrutinizes its output for errors, inconsistencies, areas for refinement. Then comes iterative refinement, where the model adjusts, revises, tries again to enhance quality and accuracy. It's this continuous, tireless loop of critique and improvement, a truly professional approach to problem solving.
It's like a perpetual editing loop for the AI.
Yeah.
But what if it needs more than just internal critique? What if it's staring at its own work and just doesn't see a glaring logical flaw or maybe a factual inaccuracy it introduced?
That's where it gets really interesting. It shows some incredible ingenuity in AI design. You can go beyond mere self-reflection by giving the LLM external tools to help evaluate its output.
External tools. Like what?
Well, for example, the agent could run generated code through unit tests to check for functional correctness. Or maybe use a web search tool to double-check factual text output against reliable sources.
Oh, okay. Fact-checking itself. Right. The agent can then reflect on any errors or discrepancies found by these external tools and come up with precise ideas for improvement. It's like giving it a pair of fresh, unbiased eyes, or maybe a whole panel of fact-checkers and quality assurance specialists. Furthermore, we can implement something called cross-reflection using a multi-agent framework. Imagine you have one agent specifically prompted to generate outputs, let's say, a complex technical report.
Okay.
Then an entirely separate agent is prompted to act as a critical reviewer. Its specific task is to identify weaknesses, suggest improvements, maybe even find potential hallucinations in the first agent's report.
A peer review, but with AIs.
Exactly. The resulting discussion or structured feedback loop between them leads to significantly improved responses. It mirrors a human peer review process or even a lively, constructive debate among professional colleagues. It allows for diverse perspectives to challenge and refine the work.
This pattern truly enhances AI's ability to evaluate and improve its own outputs. It leads to more accurate, reliable, and professionally polished results. It's like a human-like feedback and revision loop, but entirely automated, tirelessly working to perfect its creations.
And this isn't just theory. We see known implementations like powerful frameworks called Reflection and Critic. Both have demonstrated significant performance gains by integrating this self-improvement capability. As Andrew Nang highlights, it's really a testament to the effectiveness of simply giving AI the ability to think about its thinking and then act on those insights.
Okay, next up, tool use. Now, this sounds pretty straightforward, maybe like just handing an AI a simple wrench, but I suspect there's much more to it. I mean, my toaster has tool use if you count toasting bread, right? But that's not exactly agentic.
Absolutely. There's much more to it than just a simple on-off switch or a basic appliance. Tool use is about enabling LLMs to transcend their inherent limitations, while primarily being confined to producing text responses from their pre-trained knowledge base. Tool use lets them interact with external functions. This allows them to gather information, perform actions, or manipulate data outside their internal neural network. They can reach outside themselves into the vast digital world, transforming from mere information repositories into active participants.
So it's not just what they know internally, but what they can do with other external tools, like giving them access to the internet, or a calculator, or maybe even a sophisticated design software license.
Precisely. Think of it this way. If you ask an LLM, what's the best coffee maker according to reviewers? By itself, it only knows what it was trained on, which might be months or years old.
Right, outdated info.
Exactly. With tool use, it can decide to carry out a real-time web search to find current reviews. Or another example, if you ask, if I invest $100 at 7% compound interest for 12 years, what do I have? Rather than attempting a calculation that could be prone to numerical error.
Which LLMs sometimes struggle with, right? Math.
They can, yeah. So instead, it can use a code execution tool to run a simple Python command like 100, 1 plus 7.712, to get the exact answer instantly. No more guessing or approximate numbers. It provides precision and up-to-date information. And the clever part, as Andrew Ng explains, is how the seamless interaction happens. The LLM doesn't just magically do the search or calculation, it generates a special string, almost like an internal instruction note, something like tool.websearch, query, current coffee maker review.
Like a command.
Right. A post-processing step then intercepts this string, calls the designated tool with the relevant parameters, and critically passes the result back to the LLM as additional input context for further processing. It's a very elegant professional handoff system allowing for great modularity.
That's brilliant. So they're not just pulling from internal memory, they're actively going out and finding new real-time information and performing real-world actions. It's like giving them a whole utility belt of sophisticated gadgets rather than just a very big brain.
And it goes far beyond simple search or basic arithmetic. Developers are using functions to interface with the huge array of productivity tools, sending emails, reading calendar entries, interacting with databases, even generating or interpreting images. Some advanced systems have access to hundreds of tools.
Hundreds? Wow. How does it choose?
Well, they use clever heuristics, basically smart rules of thumb, to pick the most relevant subset of tools to include as context for the LLM at any given step. It's similar to how retrieval augmented generation works for text. This ensures the AI always has the right tool for the job without being completely overwhelmed by options.
The AWS team highlighted this too, that tool use truly expands AI's capabilities. It allows them to gather the latest information, process data, or update external systems. It really makes them active, responsible participants in solving complex problems, not just passive answer machines.
Yeah, and a significant step that really democratized this capability was GPT-4's function calling feature. That made tool use much more general purpose and accessible to a wider range of developers. This pattern fundamentally enhances agents' knowledge retrieval, keeping them current, their updatability, data privacy, especially for sensitive on-premise data.
Because the data doesn't have to leave your network to be processed by the tool.
Exactly. And cost efficiency, because they don't need to be fully retrained for every new piece of information. It's an incredibly powerful and efficient paradigm shift.
Okay, so we've got AIs that can check their work, reflection, and AIs that can use tools, tool use, now planning. This sounds like the AI starts thinking like a seasoned project manager laying out tasks, considering dependencies, managing timelines. My personal assistant still struggles to organize a sock drawer, so this feels like a monumental leap.
Haha. In essence, yes, precisely like a highly efficient and strategic project manager. Planning is a key agentic AI design pattern where an LLM autonomously decides on a sequence of steps to execute a larger complex task. Instead of just attacking a problem randomly or in a single brute force burst, the LLM first creates a structured roadmap. It meticulously breaks the overall goal into manageable, sequential sub-objectives. It's all about foresight and strategy.
This is where it gets really interesting. Andrew Ng recounted a defining AI agentic moment he experienced during a live demo. His research agent, equipped with online search tools, unexpectedly hit a rate-limiting error with its primary web search API.
Oh no, live demo nightmare.
Right, meaning it was making too many requests too quickly. He thought the demo was toast, a public disaster in the making.
But to his genuine surprise, the agent deftly pivoted. It switched to a Wikipedia search tool which he had completely forgotten he'd even given it access to, and it completed the task seamlessly. Yeah. This illustrates the agent's remarkable ability to dynamically decide what steps to take and what alternative tools to use, even when faced with an unforeseen obstacle or a dead end. It adapted in real time, just like a highly resourceful human would without any human intervention.
A true aha moment, I imagine, seeing it adapt and succeed in ways he hadn't anticipated. That's the kind of autonomy that's both thrilling and, let's be honest, a little bit awe-inspiring. It speaks volumes about its professional independence.
Absolutely. The planning process involves several key sub-steps. First, there's task decomposition, breaking down that large goal into smaller, manageable subtasks.
Okay. Chunking it down.
Exactly. Then, strategic structuring, where it systematically organizes these steps for optimal goal achievement. This leads to efficient execution, where it carries out the plan and continually monitors progress. And finally, flexible adjustments, where it modifies and adapts plans as needed based on new information, unexpected outcomes, or feedback. This makes it particularly useful for managing long-term projects and solving complex, multifaceted problems that evolve over time. For a more concrete illustration, consider a task from the Hugging GPT paper. Draw a picture of a girl in the same pose as a boy in an input image.
Okay, that sounds tricky.
It is. The LLM, using planning, might decompose this into two distinct steps. First, detect the pose from the initial image of the boy. Second, render the new image of the girl in that specific detected pose. The LLM plans these two separate actions to achieve the complete nuanced goal. It's about breaking down creativity into logical steps. Now, while incredibly powerful and truly a leap forward, planning is still a less mature technology compared to reflection and tool use. Its results can sometimes be less predictable, requiring careful monitoring. It's not yet foolproof for every scenario.
Still needs some work.
Right. However, the field is evolving at a breathtaking pace. These planning capabilities are improving rapidly, so we can expect much more reliability and sophistication in the very near future.
Finally, the fourth pillar, multi-agent collaboration. This sounds like building a whole AI office with different AIs playing different roles, maybe even gossiping around the digital water cooler. I'm picturing little AI cubicles, each with a specialized function.
Haha. That's a great analogy. A digital dream team, if you will. It's about more than one AI agent working together, splitting up tasks, discussing ideas, and ultimately coming up with better solutions than a single isolated agent could achieve on its own. Given a complex task, like writing a significant piece of software, a multi-agent approach breaks it down into subtasks and assigns them to different specialized roles. You might have a software engineer agent, a product manager agent, a QA specialist agent, and so on. Each acts with their specialized expertise, just like a professional human team.
So why go through the trouble of creating multiple agents if it might just be different calls to the same underlying LLM? Why not just make one gigantic, super smart LLM that does everything? It sounds like more overhead.
That's a very fair and practical question, and there are actually several compelling reasons. First, and perhaps most importantly, it demonstrably works. Many teams are reporting superior performance and more robust solutions, as shown in studies like the Autogen paper. The results are measurable and significant.
Okay, so it gets better results.
Often, yes. Second, even with the impressive large context windows available today, LLMs can still struggle with truly complex, sprawling inputs that would just overwhelm a single agent. Decomposing tasks allows each agent to focus on one thing at a time with optimized, role-specific prompts. For example, that software engineer agent can be specifically prompted to prioritize clear, efficient code for its subtask, rather than trying to juggle all aspects of the project at once, from user experience to testing. Third, and perhaps most valuable for developers and system architects, it provides a powerful, intuitive framework for breaking down complex tasks. This is remarkably similar to how we use processes or threads in traditional software development to manage complexity. It's a familiar abstraction applied to a new, exciting domain, making the development and maintenance of these systems far more manageable and professional.
It's like hiring specialized experts for different parts of a complex project rather than one very overwhelmed generalist. Makes sense. So what does this collaboration actually look like in practice? How do they talk to each other without causing digital office drama?
It involves three key components: clear task division, specialized expertise, and structured communication. A supervisor agent, often the lead, might first decompose the complex problem into smaller, manageable tasks.
A project manager AI.
Kinda, yeah. It then intelligently identifies which specialized agent is best suited to call for each task based on their defined expertise. These agents can then exchange information and share results either directly with each other in a structured dialogue, or maybe by reporting back to the supervisor, who then combines the final outputs. It's a choreographed dance of intelligence, ensuring seamless handoffs and coordinated effort. And the practical implementation of this is rapidly maturing. Emerging frameworks like Autogen, Crew AI, and LangGraph provide rich and increasingly sophisticated ways to build these multi-agent solutions. You can even simulate an entire virtual software development company like the ChatDev project did.
Seriously, a whole company of AIs.
Yeah, where agents take on roles from product manager to engineer to tester and virtually build software together. It's truly a glimpse into the future of automated professional development. However, it's worth noting, and this is important while incredibly powerful, the output quality of multi-agent collaboration can still be challenging to predict. particularly when agents are allowed to interact freely with multiple tools and with each other in less constrained environments. This hints at the complexities and potential pitfalls we'll definitely explore later, as the Pond House data research highlights. It's not quite a perfectly harmonious symphony just yet and requires very thoughtful design.
Okay, that's a fantastic overview of the 4 foundational patterns Andrew Ng laid out. But you mentioned our sources, particularly that CSRO agent design pattern catalog. Go even deeper. It sounds like a comprehensive set of specific architectural patterns, like a full blueprint library for building these intelligent systems, almost a professional's handbook for agent architecture.
Indeed, this CSIR catalog is incredibly valuable. It moves from those broad strokes to much finer details. Now, instead of listing all 18 patterns, which might get a bit dry.
Yeah, maybe save that for the show notes.
Exactly. Let's focus on some key illustrative patterns within each category that demonstrate the critical design choices you face when building these. We'll start with goal-seeking and user interaction patterns. These address how an agent first understands what a user actually wants to achieve, often from ambiguous input. For instance, consider the proactive goal creator pattern. This takes things a step further than just passively receiving input. It tries to anticipate users' goals by not just understanding human interactions through dialogue, but also by proactively capturing broader context via relevant tools.
How does it do that?
It tackles the problem that limited context from dialogue alone can lead to inaccurate or incomplete responses. It's about the AI trying to infer your intent more deeply.
Anticipating, okay, that still sounds a bit like mind reading or maybe having a crystal ball. How does an AI anticipate my needs without being creepy?
Not quite mind reading, but close enough to feel like magic sometimes. In addition to processing direct prompts, this pattern sends requirements to detectors that capture multimodal context from the user's surroundings.
Multimodal, like vision and sound.
Exactly. This could involve identifying gestures through cameras, recognizing application UI layouts via screenshots to understand what you're looking at on your screen, or even analyzing sentiment from your voice tone. The crucial ethical and professional consideration here is that the agent should always notify users about this context capturing.
Transparency is key.
Absolutely. To avoid unnecessary interruptions or privacy concerns, this offers enhanced interactivity, a much more detailed goal understanding, and critically, improved accessibility for users with disabilities who might not be able to type or speak clearly. It's about the AI becoming more perceptive of its environment and adapting to your natural way of working. Now, let's look at prompt and knowledge optimization patterns. These are all about making the AI's internal dialogue and its access to information as precise and effective as possible. A real standout here is the prompt response optimizer.
Okay, sounds useful.
Very. This pattern refines prompts sent to the agent and responses generated by the agent according to desired content and format. The core problem it addresses is that users, frankly, often struggle with writing truly effective prompts for AI.
Guilty as charged.
We all are sometimes. And conversely, agent outputs can sometimes be verbose, unstructured, or just difficult for humans to understand without a clear professional standard.
So it's the editor for both sides of the conversation. It tidies up my messy requests and makes the AI's replies more digestible and professionally formatted. Sounds like a dream come true for efficiency.
Precisely. It constructs refined prompts and responses adhering to predefined constraints and specifications. Often it uses templates that contain explicit instructions, maybe few-shot examples, or the specific question for the agent to follow. This ensures standardization, strong goal alignment, interoperability with other components, and adaptability to different requirements or domains. It's really about bringing order and professionalism to the conversational chaos, making sure everyone speaks the same language. And of course, a critical pattern here is retrieval augmented generation, or RAG. You probably heard of this one.
RAG, yeah. It comes up a lot.
It's a technique that significantly enhances an agent's knowledge updatability and helps maintain data privacy, especially for on-premise deployments. The problem it solves is fundamental. Large foundation models, by their very nature, aren't equipped with specific domain knowledge or confidential local data unless they've been expensively fine-tuned. And fine-tuning, as we know, is both costly and potentially privacy-sensitive.
So instead of retraining the whole massive model every time new information comes out, like a new company policy or current events, you just give it a cheat sheet. or like a quick, up-to-date reference guide. That sounds much more efficient and practical for businesses.
Exactly. It cleverly fills these knowledge gaps by retrieving information from external authoritative sources, like your company's internal documents, a live news feed, or a specialized vector database, and then it incorporates that retrieved information into the agent's prompt.
Ah, so it gets the context right there with a question.
Right. This allows it to perform in-context learning without altering its core training. The benefits are truly immense. Reliable knowledge retrieval, continuous updatability with current facts, robust data privacy by keeping local data separate from the main model, and significant cost efficiency. It's a real game changer for keeping AI current and relevant without breaking the bank or compromising privacy. Moving into model interaction and planning patterns, these explore how agents manage their own thought processes and create those multi-step strategies we talked about. A key distinction here is between one-shot model querying and incremental model querying.
One shot versus incremental.
Okay, one-shot queries the foundation model in a single instance to generate an entire plan. It aims for maximum efficiency and speed, especially for simpler or more urgent tasks.
So one and done, like getting all the instructions for a flat pack furniture assembly in one go rather than step by step, sounds fast.
It is indeed fast. However, for more complex tasks, incremental model querying accesses the foundation model at each step of the plan generation process.
Takes its time.
It does. This directly addresses the problem of foundation models sometimes struggling to generate completely correct or accurate responses on the very first attempt. It aims for a more accurate and robust step-by-step reasoning process.
So it keeps checking its work as it goes. More thorough, but probably slower, like drawing a detailed blueprint versus a quick sketch. It's a trade-off between speed and precision then.
Exactly. The agent engages in a meticulous step-by-step reasoning process with multiple iterative queries to the foundation model, and crucially, human feedback can even be provided at any point during this process, allowing for real-time adjustment.
Oh, interesting. Human in the loop.
Right. This provides supplementary context, significantly improves reasoning certainty through iterative refinement, and greatly enhances explainability by showing the detailed progression of thought. The trade-off, as you correctly noted, is increased overhead. Multiple interactions inevitably increase both time and computational cost. But for critical tasks, that thoroughness can be invaluable. Then there are reflection and feedback loops, building on Andrew Ng's foundational concept. The catalog expands this with patterns like cross-reflection. This pattern utilizes different agents or even separate foundation models to provide feedback and refine the generated plan.
So getting a second opinion from another AI.
Exactly. It's particularly useful when a single agent might have limited capability for robust self-reflection, or when a problem demands multiple, diverse professional perspectives for a truly thorough review.
So it's bringing in a second opinion, or maybe a whole panel of expert AIs, to review the work, like a digital peer review board ensuring quality control.
Yes, that's a perfect analogy. The original agent queries a specialized reflective agent, or potentially multiple agents, to review its outputs and reasoning, providing suggestions for improvement. This can be an iterative process. The benefits are significant. Enhanced reasoning certainty and response accuracy, thorough explainability due to multiple perspectives, and scalability. However, there are drawbacks, like reliance on the performance of these other agents and the inevitable communication overhead. It's a professional team effort, digitally orchestrated. Within multi-agent cooperation schemes, beyond just reflecting on each other's work, multiple agents can actually cooperate in different structured ways to solve a problem. One elegant pattern is role-based cooperation.
We touched on this with Andrew Ng's pattern.
We did. This pattern assigns agents assorted, specialized roles, and decisions are finalized strictly according to their specific responsibilities. This helps agents cooperate effectively by leveraging their unique specialties, much like a well-structured human team in a professional setting.
Like a well-oiled machine where everyone knows their job and stays in their lane. It sounds very professional and polite, avoiding any digital turf wars.
Precisely. Agents coordinate in a hierarchical scheme, establishing workflows via persona specification. For instance, you might have a planner agent that generates the overall strategic plan, an assigner agent that orchestrates task delegation, and various worker agents that complete tasks based on their specialized expertise.
Division of labor.
Exactly. This design facilitates efficient division of labor, offers fault tolerance, you can replace inactive agents, improves scalability by adding new roles, and, crucially, clarifies accountability. It's about distributed intelligence, working in concert effectively. Finally, let's touch upon safety, tool management, and evaluation patterns. These are really the unsung heroes that keep everything running smoothly, ethically, and professionally in real-world deployments. A critical one is multimodal guardrails.
Guardrails. Sounds important.
Vitally important. This pattern controls the inputs and outputs of foundation models to meet specific requirements, user expectations, ethical standards, legal compliance. It primarily aims to prevent foundation models from being influenced by adversarial inputs or generating harmful, biased, or undesirable outputs due to hallucinations.
So it's the digital bouncer for AI conversations, ensuring safety and compliance, politely but firmly saying no to anything sketchy or inappropriate. That sounds like a vital component for trust.
Exactly. Guardrails act as an intermediate layer, diligently verifying information before it reaches the foundation model and inspecting outputs before they are delivered to the user or other components. Risky or sensitive data, like personally identifiable information, PII, can be processed or removed. They can operate based on predefined rules or even use AI themselves, and they handle multimodal data like text, audio, and video. Benefits include robustness, safety, standard alignment, and adaptability across different models. It's all about responsible AI deployment, ensuring the AI remains a professional and safe assistant. Another crucial pattern for managing all those tools we talked about is the agent adapter. This provides an interface to seamlessly connect agents and external tools for task completion. This is crucial because agents often need to deal with diverse, potentially incompatible, or maybe just inefficient tool interfaces that weren't originally designed for AI interaction. Think of it like connecting a new appliance to an old power outlet. Sometimes you need an adapter.
So it's the universal translator for AI, making sure everything can talk to everything else, even if they speak different digital languages.
Yeah.
Very polite and practical.
Precisely. It helps invoke and manage these interfaces by converting agent messages into the required format for tools and vice versa. It can even retrieve tool manuals or tutorials from a data store to learn usage autonomously.
Like an AI reading the instructions.
Pretty much, like an AI learning how to use a new piece of software by reading its manual. This significantly boosts interoperability and adaptability, allowing agents to easily employ new tools, and greatly reduces development costs by eliminating the need for manual, custom interface creation. It breaks down those communication barriers between the AI and the vast ecosystem of digital tools available.
Okay, knowing these patterns is one thing, but how do leading AI labs actually put them into practice? Moving from the blueprints to the actual construction site. It's time to turn to some real-world insights from the trenches, particularly from Anthropic, the creators of the Claude models.
Indeed. Anthropic offers incredibly valuable insights, and their core philosophy is really rooted in simplicity and professional pragmatism. Their primary advice: start simple. Only increase complexity when it's demonstrably needed and provides clear, measurable value. Often, just optimizing single LLM calls with good retrieval and well-crafted in-context examples is perfectly sufficient to achieve desired outcomes. Don't over-engineer from the start.
Let's keep it simple, stupid. The KISS principle for AI.
Basically, yes. They highlight 3 core principles for building truly production-ready agents. First, maintain simplicity in design. Avoid unnecessary layers of complexity that just obscure function. Second, prioritize transparency by explicitly showing the agent's planning steps and internal thought processes. This isn't just good for debugging, it actively fosters trust.
Right. See how it's thinking.
Exactly. And third, carefully craft agent-computer interfaces, ACIs, through thorough tool documentation and rigorous testing. Treat them with the same care and professional standards as human-computer interfaces.
So frameworks can certainly get you started, but sometimes less abstraction is more. It sounds like they're saying, don't just blindly click install all plugins if you don't know what they actually do.
Precisely. While frameworks like LangGraph or Amazon Bedrock's AI agent framework do simplify common tasks and accelerate initial development, they can also, paradoxically, obscure the underlying prompts and responses.
Hide what's really going on.
Yeah, which makes debugging significantly harder when things inevitably go wrong, which, let's face it, they sometimes will. Anthropic suggests that developers should consider working directly with LLM APIs if they need full transparency and granular control, especially as they move toward production systems. It's about understanding what's truly under the hood for professional deployment. Anthropic also shares specific, really actionable tips for agentic coding using their Claude Code tool. For instance, you can highly customize your setup by creating special files called claude.md.
Claude.md, what are those?
They're very special markdown files that Claude automatically pulls into its context when a session starts. This makes them ideal for documenting common bash commands you use, specific code style guidelines, testing instructions, or even repository etiquette. You can even tune them, just like any other prompt, for better instruction following from the model.
Ah, like leaving a personalized professional instruction manual for your AI coding buddy. That's clever. It is like a personalized instruction manual, and a very polite one at that. That's a clever way to ensure essential context is always available without explicitly prompting it every single time. It truly professionalizes the interaction.
Another key tip they provide is to meticulously curate Claude's list of allowed tools. You can customize permissions for potentially impactful actions like file writes or Git commits. This prioritizes safety and security, giving you precise control over what the agent can and cannot do in your environment. It's a vital guardrail, like giving a new employee access only to the tools they absolutely need for their job.
And giving Claude more tools, how does that work beyond just saying, here's the internet? Does it magically gain new capabilities?
Well, Claude Code inherits your bash environment, so it can access all your custom bash tools if you instruct it to, meaning it can leverage your existing command line utilities.
Okay, so it uses what's already there.
Right. It can also connect to something called MCP, Model Context Protocol servers, for more complex tools that might be external or proprietary. And a really neat feature they highlight is custom/commands. You can store prompt templates in Markdown files within a specific folder, turning common multi-step workflows into single, easy-to-invoke commands like project.fix GitHub issue 1234.
Oh, shortcuts.
Exactly. Streamlines complex operations dramatically, making interactions much more efficient and professional. They also detail common workflows that are proven effective. One is the explore, plan, code, commit workflow. This involves first asking Claude to thoroughly read relevant files, then to make a detailed plan for how to approach a specific problem, sometimes using keywords like think hard, or even ultra-think, to trigger extended computation time for more thorough evaluation.
Giving it more time to ponder.
Right. Only then does it implement the solution and finally commit the result. The crucial part, they emphasize, is asking it to research and plan first. That significantly improves performance compared to just jumping straight into coding. It's a very deliberate professional approach.
So it's not just about raw speed, but about strategic, thoughtful work, making sure it truly understands the problem and plans effectively before it acts. I like that. It's a very disciplined, professional approach to coding.
Exactly. Another popular workflow they endorse is write tests, commit, code, iterate, commit, a classic test-driven development TDD approach.
Ah, TDD with AI.
Yep. You ask Claude to write failing tests based on expected inputs and outputs, commit those tests, and then have it write code until those tests pass. Similarly, for visual tasks, there's write code, screenshot result, iterate, where you give Claude a visual mock, and it iterates by taking screenshots until its code's result precisely matches the mock. This iterative feedback loop is incredibly powerful for achieving precision. Now, for simpler safe tasks, there is even something they call safe YOLO mode, invoked with Claude dangerously skip permissions.
Dangerously skip permissions. Sounds risky.
It is. It bypasses all permission checks for uninterrupted work. But this must be used in isolated, sandboxed environments to prevent data loss or exfiltration, as the name dangerously clearly implies. It's a feature strictly for specific controlled scenarios where safety is paramount. You absolutely wouldn't use this on a production system, for example.
Use with extreme caution feature then.
Got it.
Got it. Any other clever uses for Claude Code beyond just writing and fixing code? Maybe in less obvious ways?
Yes, quite a few, highlighting its versatility. Claude Code can be used for code-based Q&A. It acts like another seasoned engineer on your team, intelligently searching the code base to answer general questions like, how does logging work? Or, what's the best way to interact with this particular module?
That would speed up onboarding.
Significantly. It also effectively handles Git and GitHub interactions, from searching history to creating pull requests and fixing failing builds. And for data scientists, it can seamlessly read and write Jupyter notebooks, interpreting outputs, including complex images and data visualizations. It's a true professional companion across many domains. The key optimization tips across all these workflows are pretty consistent, driving professional results. Always be specific and explicit in your instructions. Give images, diagrams, or URLs as context whenever possible. More context is usually better. Course correct early and often interrupt or edit previous prompts if the AI starts veering off track.
Don't let it go too far down the wrong path.
Exactly. And use clear frequently to keep the context window focused and prevent it from getting cluttered with irrelevant conversation history. It's about being a highly engaged, clear, and frankly polite collaborator with the AI.
It really sounds like you need to be an active collaborator with the AI, not just a passive observer waiting for results. It's truly a partnership where effective communication is key, just like with a human colleague.
That's precisely it. They also explore multi-Claude workflows, which involve running multiple Claude instances in parallel. For example, one Claude writes code, and another entirely separate Claude verifies it, providing distinct contexts, which can lead to better results. Or, using Git work trees allows running multiple Claude sessions simultaneously on different independent tasks from the same repository without conflicts. It's all about optimizing the human-AI workflow for maximum efficiency and professionalism, not just the AI's internal processes. And Anthropic's recent deep dive into their multi-agent research system provides incredible insight into building truly complex AI teams. This system uses multiple Claude agents to explore complex topics. It excels at those really open-ended problems where the steps are difficult to predict in advance, mirroring how human researchers conduct investigations. Think of it as a digital think tank.
It sounds like a superpowered research team, a digital think tank capable of tackling immense intellectual challenges. What makes it so effective at handling those really hard, ambiguous problems, the ones that might stump a single human researcher?
It leverages two powerful principles: parallelization and information compression. Sub-agents operate in parallel, each with their own context windows, exploring different aspects of a question simultaneously. Then they condense the most important tokens and findings for the lead research agent to synthesize.
So they divide and conquer, then report back.
Exactly. This separation of concerns reduces path dependency, meaning one agent's decision doesn't overly constrain another's and enables thorough, independent investigations across multiple avenues. It's like having multiple researchers pursuing different leads at the same time, pooling their findings, and their internal evaluations show dramatic results. A multi-agent system with Claude Opus as the lead agent and Claude Sonnet sub-agents actually outperformed a single-agent Claude Opus by an astounding 90.2% on their internal research evaluations.
90%, that's huge.
It is, especially for breadth-first queries, those requiring wide exploration. Their analysis revealed that token usage explains about 80% of this variance. These architectures effectively scale token usage way beyond single-agent limits, enabling deeper and broader exploration that a single agent simply can't match.
That's a massive performance gain. But I imagine there's a cost, right? Perhaps in tokens or computational resources for all that parallel processing. Nothing in life is truly free, especially in advanced AI.
Indeed, you're absolutely right on the money there. These architectures do burn through tokens fast. Agents typically use about 4 times more tokens than a simple chat interaction, and full multi-agent systems use about 15 times more tokens than basic chats.
15 times.
Yeah, so this means they require tasks where the value of the outcome is high enough to justify the increased computational cost. For complex research where saving days or weeks of human effort is the goal, this cost is often well worth it. It represents a potentially very high ROI. The system employs an orchestrator-worker pattern, a classic professional design. A lead agent coordinates and dynamically delegates tasks to specialized sub-agents in parallel, dynamically finding information as needed. This is a key distinction from static retrieval augmented generation, which just fetches pre-indexed chunks. This multi-agent system actively searches, adapts, and synthesizes in real time. For these multi-agent systems, they found that careful prompt engineering was a primary lever for improvement. Key principles include: think like your agents using simulations to watch agents work step by step to diagnose failures and understand their reasoning. Almost like a digital post-mortem analysis.
Getting inside their heads.
Kind of.
Yes.
Also, teach the orchestrator how to delegate, giving sub-agents really clear objectives, specific output formats, precise tool guidance, and explicit task boundaries to avoid duplication of effort.
It's like carefully writing highly detailed job descriptions for your AI team members, making sure everyone knows their role and avoids stepping on digital toes. That's a truly professional management approach.
Exactly. Another principle: scale effort to query complexity. Embed rules in prompts, like assigning just one agent for simple fact-finding versus maybe 10 or more for complex, open-ended research. Also, tool design and selection are critical. Each tool needs a distinct purpose and a clear description, and agents need explicit heuristics, those smart rules, for tool usage to avoid sending them down irrelevant paths. And crucially, let agents improve themselves. Claude 4 models, they found, proved to be excellent prompt engineers themselves. They could diagnose failures and suggest improvements to their own prompts. They even created a tool testing agent that automatically rewrote flawed tool descriptions to avoid future
Whoa,
errors.
self-correcting tool.
Yeah, a self-optimizing process that reduced task completion time by a remarkable 40%.
Wow, AI improving AI. That's a true mind bender, a self-optimizing digital ecosystem. What other strategies did they find useful for boosting performance and professionalism in these complex systems?
Starting wide, then narrowing down searches, exploring broadly before drilling into specifics, much like a good human researcher would. Guiding the thinking process using that extended thinking mode as a scratch pad for planning, giving Claude more internal computation time for thorough evaluation before it commits to an action, and critically, utilizing parallel tool calling, which cut research time by up to 90% for complex queries by allowing subagents to use multiple tools simultaneously. These strategies significantly enhance both speed and depth, delivering professional-grade research in record time. Now, in terms of production reliability, this is key. Multi-agent systems are highly stateful. They maintain an internal state across many interactions, and errors can compound catastrophically if not handled correctly.
The cascade effect we talked about.
Exactly. They need robust systems that can resume from specific error points rather than restarting from scratch every time. Debugging is also harder due to non-determinism. The same input doesn't always produce the exact same sequence of internal steps. This requires full production tracing and high-level observability of agent decision patterns to understand what went wrong. Deployment needs careful handling, like rainbow deployments, to gradually shift traffic without disrupting running agents. That's standard professional practice for high availability systems. And currently, subagents often execute synchronously, which can create bottlenecks. Asynchronous execution, allowing them to work truly independently, is a key future goal to unlock even greater parallelism.
Makes sense.
Oh, and a final key tip to minimize the game of telephone between agents: have subagents output structured data directly to a file system, passing only lightweight references back to the coordinator. This preserves fidelity and significantly reduces token overhead, leading to more robust and cost-effective solutions.
Okay, we've heard about the incredible potential and some really clever solutions for building these agentic systems. But as with any complex technology, there are pitfalls. These systems can, and sometimes do, fail. And there's a recent, very insightful paper titled, "Why Do Multi-Agent LLM Systems Fail?" that dives deep into the systematic failures. It sounds like a critical read for anyone building or relying on them, a sort of Murphy's Law for AI, but hopefully with actionable advice.
Absolutely. This research identifies 14 distinct failure modes, categorized into 3 primary levels. Understanding these is crucial for designing robust, reliable systems, avoiding common pitfalls, and ensuring professional performance. Let's start with single-agent failures. These are foundational limitations within individual LLM agents themselves, the basic building blocks where vulnerabilities can start. These include things like prompt engineering issues, where ambiguous instructions, overly constrained prompts, or just sensitivity to slight changes in phrasing lead to agents ignoring explicit requirements or producing inconsistent results.
Garbage in, garbage out, essentially.
Pretty much. Then there's context handling deficiencies, like those fixed context window limitations we mentioned, the frustrating tendency to hallucinate information when context is incomplete, or losing conversational history across turns, which leads to inconsistent decisions. It's like asking a human to remember every single detail of a long conversation perfectly.
So if the base agent isn't strong, if it has a shaky foundation, everything else built on top of it just crumbles eventually. It's like trying to build a skyscraper on quicksand.
Exactly, the metaphor holds true. Also in this category are reasoning limitations, such as inherent weaknesses in logical inference, struggling with multi-step reasoning, or handling quantitative operations inaccurately, all of which can lead to task derailment. And finally, instruction following challenges, where agents just struggle to adhere to specific instructions or structured output formats, often causing repetition, partial implementations, or a gradual drifting from the original objective. These are fundamental issues that must be addressed professionally before you even think about complex multi-agent interactions. Moving up a level, we encounter multi-agent interaction failures. These are issues that specifically emerge when agents try to interact and coordinate with each other. Think of them like communication breakdowns in a human team.
Right, the team dynamics go wrong.
Exactly. Communication failures are common, manifesting as inconsistent message formats, incomplete information transfer during handoffs, or even agents effectively withholding info from each other, either intentionally, which is unlikely, or more likely due to poor design. Then there are collaboration issues and conflicting goals, which arise from ambiguous role definitions, misaligned objectives between agents, or agents simply ignoring inputs from others, leading to redundant work or conflicting outputs. And then there's inefficient interactions and resource consumption, excessive message passing, redundant context processing, leading to high token consumption and increased latency. And most critically, amplification of individual agent failures. This means even small errors at the single agent level can compound into those catastrophic cascade effects throughout the entire multi-agent system. It's like that tiny crack in a dam turning into a full breach. Finally, we reach the most complex level, compound system-level failures. These are emergent behaviors, unpredictable errors that arise from the intricate interplay of the system architecture itself. Think of emergent failures like system oscillations, where agents repeatedly reverse decisions, or deadlocks, where agents endlessly wait for each other's outputs, grinding the whole system to a halt.
System gridlock.
Precisely. Cumulative failures involve the gradual accumulation of minor errors over time, leading to a progressive degradation of output quality, a slow but steady decline, much like technical debt building up in software. And critically, human-agent interaction problems. This includes misalignment between human intent and the AI's actual actions. The AI does something technically correct, but it's not what you meant.
The be careful what you wish for problem.
Exactly. Also, ineffective human oversight mechanisms for complex agent interactions, or agents failing to clarify ambiguous instructions, the fail-clarify mode, where it just plows ahead with a bad assumption instead of asking for help. Lastly, system design failures stem from suboptimal agent topology, like an inefficient network of connections or just excessive complexity in the architecture without providing corresponding performance benefits.
This really raises an important point. If you're going to build these complex systems, understanding where they break is half the battle. This research sounds like it provides a fantastic roadmap for accountability and reliability, a digital forensic report for AI, guiding professional developers away from potential pitfalls.
It truly does, offering a clear path forward. And thankfully, the paper doesn't just point out problems, it provides extensive mitigation strategies categorized similarly. For agent design fundamentals, it recommends clear task and role specification with explicit boundaries and prohibitions for each agent, like a very precise job description. Also, prompt engineering for reliability, using structured templates, explicit verification instructions within prompts, and requiring step-by-step reasoning. Furthermore, modular agent architecture is crucial. It advocates for a single responsibility principle for each agent. Each agent does one thing, well-standardized interfaces between them, and isolating critical functions to contain potential failures. This is standard professional software engineering best practice applied here.
So design it like solid modular software from the ground up, with clear responsibilities for each component. A very disciplined, professional approach.
Exactly, treating agents like well-engineered software components, not mystical black boxes. For interaction and communication design, strategies include structured conversation flows with explicit protocols and message typing between agents. Verification mechanisms like cross-verification loops where one agent explicitly verifies another's output before it proceeds. And clarification protocols, instructing agents to request clarification when their confidence falls below a defined threshold rather than making risky assumptions. It's about building politeness and prudence into the core interaction design. In system architecture and orchestration, they suggest topology design with hierarchical oversight and clear feedback loops, ensuring proper coordination. Workflow optimization through techniques like context caching, progressive disclosure of information, only give agents info when they need it, and dynamic agent activation to only invoke agents when truly necessary, saving resources. And robust error handling and recovery with explicit error states. Graceful degradation, meaning the system can continue operating with reduced functionality rather than crashing completely, and human intervention triggers for critical situations. Finally, for implementation and testing strategy, the advice is straightforward but vital. Incremental development, starting with minimal viable agents and gradually adding complexity of phased rollout approach. Systematic testing methods that specifically simulate known failure modes and conduct adversarial testing, deliberately trying to break the system to find weaknesses. And, crucially, a continuous improvement process to categorize observed failures, perform root cause analysis, and implement targeted interventions, constantly refining the system through a professional feedback loop. The key implementation principles distilled from all this are really profound, I think. Clarity trumps complexity. Simpler, well-defined roles often outperform overly sophisticated designs. Verification is not optional for every output. Critical checks are paramount. Conversation structure creates reliability. Clear communication protocols prevent breakdown. Modularity enables resilience, isolating problems stops them from spreading. And incremental complexity is key. Only add complexity when demonstrably justified. These are the actionable engineering approaches that directly address the core technical challenges of building reliable, professional agentic systems.
Okay, with so many powerful patterns and these critical considerations about failure, how does a practitioner actually decide which paths to take when building an AI agent? It still seems like a potentially dizzying array of options. Thankfully, you mentioned the CSIRO Agent Design Pattern Catalog offers the decision model, like a flowchart for intelligence, to help guide the selection process.
Exactly. This decision model is invaluable as it visualizes the entire selection process. It shows how each design problem you might face can map to a specific solution space, often with alternative or complementary patterns. It clearly highlights the strengths and the inherent trade-offs of each pattern, offering a systematic, professional way to think about agent architecture rather than relying on costly trial and error. So, for example, if your agent needs to capture a user's environmental information as supplementary context, perhaps for accessibility or just richer understanding, you might choose a proactive goal creator. But if you just need a simple, efficient dialogue interface that subtly enriches user input behind the scenes, a passive goal creator is the straightforward and likely more cost-effective way to go. It helps guide you to the right tool for that specific job.
So it truly helps you pick the right tool for the job,
Mhm.
rather than just grabbing the fanciest one or maybe the one that made the splashiest demo video last week. It prioritizes effectiveness over flash.
Exactly. If prompt optimization is needed for standardization or strong goal alignment, the prompt response optimizer is your professional choice. If you need external, up-to-date, or private data to enhance the model's knowledge base, RAG, Retrieval Augmented Generation, is the go-to solution. When querying the foundation model, do you need to query it multiple times for detailed explainability and high reasoning certainty? Then incremental model querying is suitable. Or, if efficiency and cost efficiency are paramount, one-shot model querying is likely preferred for speed and budget. For plan generation, if you need multiple choices in planning to align with human preference and ensure inclusiveness, giving the user options, choose a multipath plan generator. For a linear, efficient approach where direct route is best, a single path plan generator is ideal. And when reflecting on generated plans, you have that clear choice of self-reflection, the agent critiques itself, cross-reflection, other agents provide feedback, or human reflection, involving user feedback for ultimate alignment with human intent and values.
It's like a comprehensive flowchart for building AI, anticipating the challenges and guiding you to the most appropriate solutions with professional foresight. This makes the whole process seem far less daunting and much more, well, methodical.
Indeed. If multiple agents need to collaborate, you can opt for voting-based cooperation, great for consensus, role-based cooperation, excellent for clear division of labor and accountability, or debate-based cooperation, good for iterative refinement through structured argument. To control the foundation model's inputs and outputs for safety and compliance, multimodal guardrails are absolutely essential, acting as that polite but firm digital bouncer. If you're using external tools or agents, a tool agent registry enhances discoverability and selection efficiency, and an agent adapter ensures interoperability between potentially disparate interfaces. And finally, to assess the agent's performance rigorously, the agent evaluator is the pattern to implement, ensuring functional suitability, adaptability, and continuous professional improvement. This decision model, with its clearly highlighted strengths and trade-offs for each pattern, moves practitioners from a potentially costly trial and error approach to a much more systematic architectural design process for their foundation model-based agents. It's really about building with intention, foresight, and a high degree of professionalism.
What an incredible journey we've been on. We've truly unpacked the core concepts of agentic AI, drawing that clear distinction between true autonomous agents and the more structured agentic workflows. We explored the 4 foundational design patterns from Andrew and Nay that are driving so much progress right now. And then we delved into some of the sophisticated architectural patterns from the CSIRO catalog that guide the creation of these incredibly complex systems. We've seen how real-world practitioners at Anthropic are building effective agents with clever, practical workflows. And critically, we've shone a light on why agent systems can sometimes fail and, more importantly, how to mitigate those risks, thanks to those invaluable insights from Pond House data. And finally, we've learned how a decision model can help navigate this fascinating, rapidly evolving landscape with precision and professionalism. So you, our listener, now hopefully have a robust mental framework for understanding how these incredibly powerful AI systems are built
and how to approach them, whether you're a developer, a product manager, or just intensely curious about the future of work. This deep dive should give you a significant shortcut to being truly well-informed, maybe giving you a seat at the table in this important conversation.
Absolutely. And remember, this field is evolving so rapidly, with knowledge constantly being applied and refined almost daily. So instead of just being passive users of AI, how might you start thinking about the intentional professional design of AI, even in your daily interactions? What complex, open-ended challenges in your own work or life could perhaps be reframed as an agentic problem, maybe ripe for an AI assistant to tackle? Consider the ethical implications, the accountability, and the incredible potential of handing over more agency to AI, always, of course, with a healthy dose of critical thinking and thoughtful oversight.
The beauty of this field is that it's still being written every single day. Your insights, your questions, and your willingness to experiment responsibly are what will truly shape the future of AI. So keep learning, keep questioning, and maybe even start designing your own future agentic solutions with a new, informed perspective. From the deep dive, happy learning, and may your future AI assistants always be polite and exceptionally professional.